The Great American Solar Eclipse, August 21st, 2017. And I'm making a PowerPoint to actually show some pictures that I took, as well as some pictures that I didn't take, as well as a few pictures that I took off the internet. But anyway, this is the path of the total eclipse, and you can see it actually came in Oregon, and it went out to South Carolina, and the maximum they actually said was going to be in Carbondale, Illinois. It actually turned out it was around here in Kentucky. A long time ago, more than a year ago, we actually got a hotel in St. Louis, and what we ended up doing is driving down here. And what you want to do is understand that these lines actually talk about how much totality there was. So you had 90% blocked out there and 80% and 70%. If you were in somewhere in the same thing down here, this is the only path of totality, and the closer you are to the center, the longer this eclipse lasts. And the maximum was 2 minutes and 41.5 seconds. I actually saw 2 minutes and 35 seconds, so it actually was pretty darn close, and had perfectly clear skies. Actually, with cumulus clouds, but it cleared out, and we got to see every single second of that 2 minute and 38-second eclipse. Okay, so a little bit of terminology for eclipse. There are three types, actually four types of an eclipse. We have what are called a partial eclipse, and a partial eclipse happens no matter what type of an eclipse you're going to get. And all that means is part of the sun is blocked out by part of the moon. The annular eclipse is actually when the sun is actually too big, and sun is actually too big or the moon is too small to cover it up. And that happens when we actually have aphelion, where we actually have a relatively small sun, or we have perihelion, where we're actually closer to the sun, which happens in January, where we get a big sun. And we also have what are called perigee, big moon, and apogee, small. So if we actually get this moon trying to cover up this sun, we get what's called the annular eclipse. If we get this one trying to cover up this one, we may actually get an annular, and sometimes turning into a total solar eclipse. And then if we get this one covering this one, we may actually get a much longer eclipse. And that's probably when we actually get the 7.5 minute eclipse, which is the largest one we can get. And then we have a total eclipse, which is what everybody wants. And then we have what are called hyper eclipses, and they actually start out being annular, and either the moon is getting closer in its orbit during the eclipse and covers it up, or the sun is getting farther away and getting smaller and it covers it up and it turns into a total solar eclipse. And from 2000 before Christ to 3,000, 5,000 years, all the eclipses, we have about 12,000. You can see partial eclipse, you can see annular eclipse, and the partial, they're actually saying that's all there was. And the annular, it started out as a partial but became an annular, and the total started out as a partial becoming a total. And you can see the hybrid eclipse down here only make up about 5% of all the known eclipses. So these are all about a third, some a little smaller, some a little bit bigger, but everybody wants to see this total eclipse, and they'll travel everywhere to see it. Okay, so here are all the total and annular eclipses, as well as hyper eclipses. If you can make out that color, I really wish they would have used like green, but I guess they use that for the countries. They should have picked plaid for this one. And I think this is what this color is, so that may be a hyper eclipse, and I think the rest of these are red. And the eclipse, this is actually the 2040, and you can actually see there was one that went really close. This happened, this actually will be in 2024. Will actually be right there. So this is actually looking into the future. This is the next eclipse, and it's going to be maximum here in Mexico. I'm hoping I'm going to be here in San Antonio, which is just a little bit above it, and drive down into see it. This will last about 3.5 minutes, so it's about a minute longer. You can see the ones up here look like they're a lot larger, and that's only because of this. When you guys get into mapping, you'll actually see the expression of this map. Actually tends to make the North Pole really big, about as big as what the equator is, and it actually distorts the map greatly. So the eclipse sizes are really perfect here right along the equator, and the farther you get up north and south, the more they get exaggerated. So here are the eclipse from 2001 to 2050, and this was the eclipse that we just saw. And here's the one in 2024. It's going to be on April 8th. Mark your calendar. And then there'll be another one here in 45, which is actually going to be even better. And I don't see where the maximum is on this one. Is it on this one? 2000. This one doesn't show 2045. And you can see this goes 50 years up to 2050, and then after that you can see other ones. So there'll be one in 2099 which goes there, 78 which comes there, and this one in 62 going there, and then one down here in 71. Where was I? I was actually in St. Louis, Missouri, and I drove a little bit farther south to a county called Jefferson, and I went to Jefferson College. They actually opened it up for all kinds of things. The field house actually had kid activities, also with telescopes. The softball actually launched hot helium balloons that went up to actually sample temperature and pressure changes. But there were people on the median for the parking lots. They had lots of activity up here in the square. And where was I? I actually was on a picnic table with my wife, and we actually sat right here. We had lunch, and we could come out and look at the sun with our safety glasses, and I could go over and help look through the telescope over here. I had met a gentleman, I think was on this piece of grass. He's actually took a couple pictures and emailed them to me, and I'll show you those. And so we were standing right there, and how did I appear? This was me. Safety glasses. I'm actually in the shade. I'm not looking at the sun at this point. We would actually look at it probably every 5 to 10 minutes, because if you looked at it all the time, you didn't really see the change. And what did we see? We saw the moon photobomb the sun. This is the arch in St. Louis, and from St. Louis they had a little bit of totality, about 1 minute and 15 seconds, I think. So we drove farther south to get closer to that midline, but this was in the path of totality, and they actually showed the moon coming in with time, and then you actually got to see the total solar eclipse. Okay, here's another picture of the moon actually getting closer. Got this one off of Earth sky, I think, and you can see the moon is pretty good sized, but it wasn't as big as it normally is. This is the eclipse viewed from the International Space Station, and you can see the shadow. Most of the planet doesn't get to see this thing, and the shadow and you can see a penumbra. As you actually see the darker part, this is probably 50-60%, and the 70-mile section for this one eclipse umbra would be in here. A really cool video to watch is an airplane, Alaskan Airlines airplane, that actually went through. This was an eclipse. I'm not exactly sure when it was, but they actually got Alaska Airlines to fly from Alaska to Hawaii and fly underneath the shadow. So they actually had to time it really well, because it happens really quickly. Moves at about 1,400 miles an hour. Okay, so this is a picture that I was emailed, and this is a picture of the total solar eclipse. And you can see beautiful corona coming out. Sometimes you can actually see prominence, which is kind of a pinkish color. This is a picture that actually came from New Madrid, Oregon, so this was before the other picture. I got this one off the internet. This one is a much clearer picture. I don't know what kind of camera the person used, but it looked better than this picture, although this is still a phenomenal solar eclipse picture, much better than I was able to get. And here's another picture that the guy emailed me, and if you take a look, you can see the coronal expression in that picture. And then you can look in this picture and you can see how it changed over the about hour, probably 45 minutes between Oregon and where I was in Missouri. And here's a picture, same thing, and you see the cumulus clouds there. We still got to see this is a relatively thin cumulus cloud. We still got to see this one. And then here's a picture of the whole thing. The moon actually came in. And then you actually either saw what are called Bailey's beads if you saw lots of little things, or you saw what's called a diamond ring. This would be more like the diamond ring, and these are more like Bailey's beads. And as the moon actually comes over, and the sun and the moon are moving in this direction, and then it moves past, and you can see a diamond, maybe Bailey's beads on this side and a diamond ring on this side, and then a partial eclipse, and you saw partial, 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 total, partial, 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 and then eventually it moved off and you didn't get to see it at all. This is called first contact, and this would have been last contact. Okay, so this is me, my pictures. I'm taking pictures of the ground. When the sun actually got to, or when the moon actually got almost to it, I took a picture. You can see the beautiful cumulus clouds that I was really afraid would block out part of the total eclipse. And then as the moon actually progressed, I took another picture about 15 minutes later, and you can see, I think, not too much change. And then another 15 minutes, not too much change. And then you actually see the sun is mostly blocked, but you look at the sky, or on the ground and the sky, and not much change. And part of this is due to the fact that your eyes are adjusting to the darker sky. And then you get to this point where the moon is almost touching the sun, and you look outside and it's a little darker than this one, but it's not dark by any means. So even at 99%, it doesn't get totality. And it's really important to get inside that totality 70-mile swath on this particular one. And then here's a picture of totality. And you can see the night lights actually came on. There's one here by the side of the building that lit up, and there's one over there that lit up this part of the sky. You can see that bus stays there, but that's it. And then the last picture, this was actually from Sun Valley, Idaho, and you actually got to see the temperature drop from 12 midnight to about 8 in the morning, and then the temperature went back up. And if you actually take a look, here's the 21st, here's the 20th temperature, and you can see it did this little spike a little warmer than it did here and a little earlier than it did here. But as it went up, and then if you take a look at solar radiation is this line that actually starts at 7 o'clock as the sun comes up. And then as totality started, solar radiation went down, and during totality it went all the way down. And what did that do to the temperature? It lags a little bit behind. You'll learn that with meteorology. Temperature went from 68.9 down to 59.4, so almost a 10-degree temperature change. And then it was almost like it was 9:30 in the morning where it heated up, and it still did a pretty decent job getting up close to 90, actually 83 degrees in Idaho. We were 90, I think 95 degrees later in the day. But anyway, solar eclipse can have an effect on meteorological points as well. Okay, that's it. Thank you much. Bye.